Okay, so in today's lesson, we are going to derive the homostate pressure, which is one of the conjugative properties of solution. Like we have four properties of solution. So the formula for that is we can say pi is equal to m arrow t. So this is the formula for finding homostate pressure, which is one of the conjugative properties of solution. So have you ever asked yourself where this formula came from? And when you look here, the fact remains that R is the universal gas constant. So once you see this, it should definitely tell you that it comes from the ideal gas equation. Likewise, you are seeing T being attached to it, that is the temperature. So to derive this, we can firstly hold this constant. We hold this constant because it's our working formula. It's a main formula right there. So we can now write down the ideal gas equation, which says that PV is equal to N arrow T. PV is equal to N arrow T is the equation for the ideal gas. So P represents pressure, V is the volume, N is the mole of mole, and R is the universal gas constant, wherein T is temperature in Kelvin. So from this equation, this formula was formulated. How? If you look here homostate pressure, that is it right here, but it is in different form as pi, because homostate pressure mostly talking about water molecule in different aspects. If you hear the word homostate, mostly it talks about water. Okay, so to derive this now, we have R on this side, and we have R right here. We have T and we have T right here. We have mole, but there is no mole here. So what comes to your mind? And you know fully well that if you can capture the formula for molarity, which says that molarity, capital M, is equal to mole of the solute divided by the volume of the solution in liter. So if you look here keenly, now that you have N here and you can see M here as a whole, you have a small n here and small n here, you have volume here and volume here. This just telling you that this is a particular unit for which the volume is in, which is in liter. So to derive this now, we can try to send this across. What is that? We can send V across. If we do that, we can divide here by V and here by V. What happens? If this is done, this V cancel with this V, you're not left with P, which is the pressure. So P is equal to N RT or divided by V. So this is pressure and this is homostate pressure, which is mostly rated as pi. So the next step is, after you have done this, you capture what you have written from the previous step, which says molarity, capital M, is equal to mole of solute divided by the volume of the solution in liter. So you have mole here and you have volume here, which gives you molarity. Molarity, not molality, normality. Okay, so if you capture this right now, if you capture this in here and that of this volume, it tells that anywhere we see N expressed over V, we should place capital M there, because if you want to condense them, you can just put this M right here. In short, or in other words, you can just leave this and this here. This becomes also the formula for osmotic pressure, but it appears differently. To make it a little more standard, we can replace mole and volume by capital M. Therefore, we can say that P now is equal to, so mole over volume, it gives our molarity. So once we see this, we can now replace it as capital M. We got this our constant and this T. Since we are dealing with osmotic pressure, the key word is pressure. So this now we can change this to be bar because it is now osmotic pressure. So you just change this P right here as bar is equal to M arrow T. So it was how this particular formula was formulated from the ideal gas equation. I hope you have understood this and you learned something new. So let's say we want to like extend this formula in different aspects. We now have pi is equal to M arrow T. And if you look also here, get something clear, this is our actual formula that we have solved for. It was what we were looking for. We just want to go there by giving additional idea or clue on something, but this is our main answer. So let's say if you reach right here, this is the actual answer we are looking for, or we have been looking for. So get that clear. We are doing something extra to give it a taste or different flavor. So if we have P is equal to N arrow T, this is mole. So what is the formula for mole? We can say mole, small n is equal to mass or molar mass or molecular weight or formula weight. So anywhere we see mole, we can also put mass or molar mass times arrow T. Or we can just do it like this. Times arrow T. So here now we have the Cp as pressure. And in this case now we want to make the molar mass the subject of this equation. Maybe you're given a problem, it says you solve for the molar mass in an ideal gas equation. How will you do that? You have to do this, right? So you express this over 1 to balance it. 1 times M is just M. 1 times RT is equal to pressure times molar mass is pressure times molar mass. What we want to find here is the molar mass. So divide both sides by pressure. Divide both sides by pressure. Pressure cancel pressure, you have what? Molar mass. So molar mass now, we can say therefore because it's on the side of the equation, we want to bring it at the front. So we say therefore molar mass is equal to what? M. The M is the mass, M times arrow times T. So this becomes the formula for molar mass. So we have derived two additional formulas here. So we derive molar mass from this and that of the what we call osmotic pressure. Hope you have learned something new. It's just simple. Keep it up, and I hope you have learned. And don't forget to follow my page. Keep following, for which you are going to learn something extra. It's just a simple stuff we are doing here. So have a blessed day. See you